So continuing on, what happens when we are to be solving for an unknown angle? So I've got two examples to try with you here, and let's just carry through them. The first thing we're going to do is we're going to label our three sides, right? So looking right here, that's a hypotenuse. And spotting my angle right here, I know that this is the adjacent, and I also know that this is the opposite. Okay. With the information that I have, I know that I don't need the opposite because I'm going to be using the hypotenuse, right? I need that number. I need the adjacent. There's a number there. And my missing thing that here I need to find here is just that. That is the angle. So can you figure out what we need here? It should be cosine. You should be thinking ca, right? So you're like cosine of theta is equal to adjacent over hypotenuse, and you just write that out automatically. And the next thing you're going to do is the process of substitution and solving. So here we go. Cosine of theta, but we're going to use x is equal to adjacent, which is 109, and the hypotenuse, which is 134. And you've gotten so far, which is pretty good. However, you want to isolate x, and right now x is being multiplied by cosine. So in order to get rid of the multiplying by cosine, you of course want to divide by cosine on both sides. And instead of dividing cosine by both sides, we're going to multiply both sides by the opposite of cosine. That's cosine inverse. When you do that, what actually happens is you get x is equal to, and you're going to write cos inverse of 109 and 134. Okay, make sure you punch that in properly into your calculator, and you'll be able to get your answer. On your calculators, it might be second function and then cos, or shift and then cos. 134, and we get 35.5673, and we got to round this. 35.5673. Right, and we need to round this to the nearest whole number because we are talking about angles. So the best thing we can do here is look at this number. That is a 5. It'll turn this 5 into a 6. So we got 36 degrees. Okay, good. Let's continue it on. So with the next one over here, we're going to follow the same process and do some labeling. Hypotenuse. This is my angle, so this is my adjacent. And this is my opposite. Out of these three, it looks like I don't need the adjacent. I need two of the sides. So let's use what I have here. O and H, I should be thinking so, right? SOH from SOHCAHTOA. So I'm saying sine of theta is equal to opposite over hypotenuse. And let's just carry it through. Subbing in. 5 and h, which is 8. And we have to do sine inverse on both sides. And if we do that, we have theta on this side is equal to sine inverse of 5 over 8. And theta will be equal to 38.682. Looks something like that. Of course, we got to round it to the nearest whole number. I'll call that 39. Okay, because that 6 will push the 8 to the 9 degrees. And that's how you work it with an angle. Okay, so it's natural now to move forward into talking about word problems. What do we do in word problems? First one. It says, a sailor wants to anchor his sailboat 40 meters from a lighthouse that is 15 meters tall. Determine the angle of elevation from the sailboat to the top of the lighthouse that will result in this distance. So I've taken a time to actually draw it so we could save time on our videos. And you can see the sailboat right here. And the sailboat is looking up at this lighthouse. And I did draw it, from left to right according to what appears. So we're talking about a sailor and a sailboat and the lighthouse. And I even got this like highlighter, really cool triangle to put right there. So it looks pretty good in my opinion. let's take a moment and write in the information that we have. So the sailor wants to anchor his boat 40 meters from the lighthouse. So 40 meters from the lighthouse goes right here. Okay, and we know that the lighthouse is 15 meters tall, so I'm going to write 15 meters tall. Determine the angle of elevation, and that is going up right here from the sailboat to the top of the lighthouse that will result in this distance. One more thing to remember is that we are talking about a 90-degree triangle right here. It's got to be 90 degrees. Okay, so let's take a moment and fill in what we know. Okay, we've got the hypotenuse, we've got the adjacent to our angle, and we've got the opposite. And out of these three, we do not need the hypotenuse. I'm not asking you for the distance from the sailboat directly straight to the lighthouse. We are working with the adjacent and the opposite. So between, the adjacent, opposite, and the angle here, we're going to indicate the angle with a theta symbol. Let's try to fill it in. So I'm thinking adjacent and opposite, that is TOA. And you can try it yourself. I'll pause the video. All right, did you get this? You'll see the TOA substitution in, do tan inverse on both sides. Oops, tan inverse. Indicate that, right? Of 15 over 40 and get 20.556, which works out to be 21 degrees. Okay, and you can wrap it up with a statement and say, therefore, the angle of elevation is 21 degrees. Next up, from the top of a fire tower, a forest ranger sees his partner on the ground at an angle of depression of 40 degrees. If the tower is 45 feet in height, how far is the partner from the base of the tower to the nearest tenth of a foot? So we are talking about feet, and we've got some details here. Okay. Okay. So what you're going to see is I've drawn in a triangle, but really I've taken the time to draw the fire tower right here, right? And we also have the partner, but it's an interesting situation because we are talking about an angle of depression. That means when you're looking out on the horizontal, we have an angle of depression of, let me take out that, right, an angle of depression of 40 degrees. And they're looking down at the partner. So that means you have the 40 degrees angle of depression on the outside of the triangle, which means that the triangle will have the angle of depression right here, 40 degrees. Okay, and you can imagine that's alternate angles because we have a parallel lines and we have a transversal going through, which means if this is 40 degrees on the outside, it's 40 degrees on the inside right there. So if that's the case, we got to fill in the rest of the details. Okay, I also know that it's 45 feet. You can use a little apostrophe to indicate feet. And how far is a partner from the base of the tower? I'm sorry, 45 feet is the height of the tower. Let me get that right. 45 feet is the height of the tower. How far is a partner from the base of the tower? So I'm trying to figure out the distance right here. I can use a lowercase letter d, right? And of course that's a right angle over there. So let's take a moment and fill it out. And no problem for us now. Adjacent there, and this is opposite. And it looks like we don't need the hypotenuse. I'm going to be using the adjacent because I need to find the letter D, and I've got 45 feet there for the opposite, and I'm going to use the 40 degrees here. So if adjacent and opposite are being used, we should be thinking TOA. So let's just do it right here. TOA, which means tan of theta is equal to opposite over adjacent. That means tan of theta, in this case, is 40, okay, is equal to opposite, which is 45, and adjacent, which is the lowercase letter d. And of course, in order, to get the lowercase letter d isolated, we can use this monkey wrench tool I've been trying to show you guys, and that puts us in a situation where we're looking like this. And you can do this all in one shot on your calculators. 45 divided by tan of 40, and you should get 53.62. 62891167, and actually, because we have to round this to the nearest foot, I got to round this to the nearest whole number in this case because it's a distance request to go to the nearest foot. So I'm going to call this 50. That 6 is going to change the 3 to a 4, so d is equal to 54 feet. Okay, and a little therefore statement would be great. Therefore, the partner is 54 feet away from the base. And that base meaning the foot of the fire tower. All right, we got one more question to do, and we're making pretty good time. A surveyor is standing 100 meters from a bridge. She determines that the angle of elevation to the top of the bridge is 35 degrees. The surveyor's eye level is 1.45 meters above the ground. Find the height of the bridge. So you can see there's some details being put in here, some little tricks. 100 meters from the bridge, she determines that the angle of elevation to the top of the bridge is 35 degrees, and the surveyor's eye level is 1.45 meters above the ground. Find the height of the bridge. Okay, so let's do that. Here we go. What we know is the surveyor is 100 meters from a bridge. She determines that the angle of elevation to the top of the bridge here is 35 degrees. Okay, and we have this little detail that's occurring, and what it's saying is that the surveyor's eye level is 1.45. This distance is 1.45 meters. And we're going to have to add this. Okay, we're going to have to add this to the total height that we find. Okay, so the request is find the height of the bridge. So the height of the bridge is equal to this distance right here. We're going to call it, we can't call it the height, okay, plus the 1.45 because the 1.45 is also right here. Okay, you guys see that? It's the same distance. So let's make an indication here that the height is equal to x plus the 1.45 eye level. Okay, because that would give us the total height of the bridge. Okay, you got to add those two together. All right, so let's just treat it like we normally would. We've got a right angle right there, and we've got some details we got to put in. No problem. We got hypotenuse, and we got if this is our angle, this is the adjacent side, and this is our opposite side. Okay, and between the three, I need the opposite for sure. I need the adjacent. That's a 100. I don't need the hypotenuse. Let's take it out. So opposite and adjacent, that's telling me to use tan. So I'm going to say tan, and actually I'm going to write the saying for it. That's TOA, and that is tan of theta is equal to O over A. Let's follow it through. Tan of 35 is equal to x over the adjacent, which is 100. And in this case, I'm going to multiply both sides by 100 so I can get the x isolated. And what I end up here is looking like, all right, 100 times tan 35. And that gives me 70.02 maybe, right? And I get, let's get back to original color. 70.02 meters is equal to x. But we are looking for the height, so let's just plug that in. The height is equal to x plus the 1.45. So the height is equal to 70.02 plus 1.45. And if you do that, you get 71.47 meters. Okay, find the height of the bridge, right? So therefore, the bridge is 71.47 meters high. Pretty nifty. All right. You know, these are, I spent maybe a little bit of time trying to work out these drawings. So, you know, if you guys like those drawings, definitely, hey, appreciate it. So at this point in time, we've got practice worksheets, right? So I want you guys to work on just trig ratio, sides and angles. Just do the odd questions like 1, 3, 5, 7, 9, so forth. Get yourselves that practice of labeling the triangles and then choosing the proper SOHCAHTOA and working out either the side or the angle, right? Sides give me rounded to the nearest 1 decimal place and angles to the nearest whole numbers. The worksheet there also has the answers at the back, so at the bottom. So if you want to do more, go ahead and get that practice in. The other part is over here, the angle of elevation and depression questions. So these are word problems, and I've assigned to you 1, 3, 5, 7, 8, and 11. So there's 6 questions there. Every time you read the problem, take a moment and draw out the diagram. Be careful about angle of depression because the angle's on the outside and stuff. Okay, other than that, that's it. Hope you guys are all doing well, and have a great day. Goodbye.